In the previous lesson, we introduced the real number system and the different subsets that make up the real number system. So natural numbers, whole numbers, integers, rational numbers, and irrational numbers. And we discussed briefly imaginary numbers and complex numbers, and then we did an example where we classified each number according to which set it belonged to. Now we're going to talk about how to represent those real numbers on something called a number line, and as well as absolute value, inequality, and a variety of little definitions that are really important to know. So the first thing is, if you look at something that looks like this, this is what we refer to as a number line. And typically we'd have 0 in the middle here, and we just go up 1, 2, and 3 in the positive direction, -1, -2, -3 in the negative direction. And we can represent any real number on this line. So if we wanted to represent, let's say, the number 2, well, we just put a dot by the 2. Maybe we should try a different color. So we can represent 2. If we wanted to represent negative 0.5, well, that would be somewhere between 0 and -1, so that would be approximately here. Similarly, if we wanted to do, let's say, negative 2.3 repeating, well, that's the same as negative 2 1/3, and that would be a little bit smaller than negative 2, so 1/3 more than that. So any point on the line represents any real number. Absolute value is represented by these two lines around a number, and what it means, that's the distance from the origin. The origin refers to the 0 point. So this is the distance from the origin to any number. So the distance from 0 to 2 is 2 spaces, or 2 units. So the absolute value of 2 would be 2. The absolute value of -2, let's say if we want to do the absolute value of -2, well, that means the distance from the origin, 0, to -2. And the distance is still 2. It doesn't matter that it's left or right or negative or positive. It's distance. It's always positive. So what absolute value does is it takes a negative number inside and gives us the positive. If it starts with a positive inside, it gives us the same positive, like these two examples. If it's negative, it becomes positive. If it's positive, it stays positive. And the reason is because we're referring to distance, and distance is a positive thing. So that's absolute value. Inequality signs are used when two things are not strictly equal, but one is greater than, less than, or equal to another. So we have 4 inequality signs: greater than, less than, greater than or equal to, less than or equal to. And we have examples here. 4 is greater than 2, -3 is less than -1, and so on. A lot of students seem to forget which way the symbol goes when they need to use it, so what I usually do is think of the symbol as an arrow. So greater than would be an arrow like this, less than would be an arrow like this, this would be greater than or equal to, less than or equal to. And you notice the arrow always points to the small number. So whichever is the smallest, that's where the arrow is going. So in this case, 4 is greater than 2, so the arrow is pointing to the 2. -3 is less than, arrow pointing to the -3. On the number line, we can think of the numbers to the right as always being greater than the numbers to the left. So if we look at another number line here, it always goes bigger to the right. So 1, 2, 3, 0, -1, -2, -3, smaller to the left. So if you need to know -1, let's say, and -4, which of those is bigger? Well, which of those is further right, because right is always greater. So if we look at the number line, which one is to the right? Well, -4 would be here. -1 is here. This is further to the right than -4. So -1 is larger or greater. So if we need to put the symbol between them, -1 is greater than -4. A reciprocal is another term that we need to be familiar with. Reciprocal, by definition, means that if you take a number and multiply by its reciprocal, the result is 1. So a number, for example 2, multiplied by its reciprocal has to give 1. So what times 2 gives 1? Well, the answer is a half. So the 1/2 is the reciprocal of 2, or the other way around. 2 is the reciprocal of a half. It works both ways. Every number except for 0 has a reciprocal, and the reciprocal of a number is 1 divided by the number. So you notice here the reciprocal of 2 is 1 divided by 2. A lot of people just think about flipping the fraction over. Okay, so that's a way to remember it. Flip the fraction. So let's work through these examples now. First, we're going to find the absolute value of each number. So the absolute value of 3 just means make it positive. It's already positive, so it stays as 3. 7/2, 7/2. -6/7 becomes 6/7. -√3 becomes √3. And that's all there is to absolute value. Reciprocal. So finding the reciprocal for each number. The reciprocal of 3, well, that's just 1/3. We flip it over or we divide it into 1. B, 4/5, the reciprocal is 5/4. -3/7, well, it's 7/3, which is the same as -7/3. It doesn't matter where the negative is. If you wanted to check one of these, let's say we wanted to check B, well, we would just multiply. There was our number. We think that 5/4 is the reciprocal. We multiply them together. The answer should be 1. If the answer is 1, then it is the reciprocal. Well, if you're multiplying this, that gives us 20/20, which is 1. So that is the reciprocal. In the next lesson, we'll start to work with some positive and negative numbers and remind ourselves of the order of operations. Until then, make sure you do some more practice and that you're familiar with the terms that we've talked about here. Thanks for watching.